So you're going to start with the mass of one of your reactants. Doesn't matter which one, okay? Start with the mass of one of the reactants. You can choose either one of them, but you're going to start with the mass of one of the reactants. Okay? From the mass of one of the reactants, you need to get that into moles of that starting reactant. From the moles of that starting reactant, you've got to find the moles of the ending, I'll put it that way, reactant in the problem, whatever that is in the end of your problem. And finally, you want to have the mass of the ending reactant. So those are the steps you're going to go through. Now, to get from the mass of one of the reactants to the moles, what do you have to calculate? Molar mass. Okay? So it has to be the molar mass of that starting reactant, whatever that happens to be. So to get from step A to step B, you've got to go through molar mass. All right? To get from moles of the starting reactant to moles of the ending reactant in your problem, what do you got to have? A molar ratio. I don't see a lot of pencils that are moving out there. Well, apparently a lot of people looking at the homework, a lot of people need to be writing it down about 15 more times. Okay? We've written it down about 3 or 4 times. Apparently 3 or 4 times isn't doing it for you. I mean, one time isn't doing it for you. A few people got the answers.
Are you fussing?
No, I'm not so much fussing as that I'm trying to, well, I've tried to, different kinds of encouragement. And this is kind of a negative encouragement, okay? Because the positive encouragement apparently isn't working too well.
So you're giving us negative encouragement?
Do the work. How's that for you? Does that work better? Copy this down. How's that working for you? Is that clear? Okay, good. Yes?
So nobody, I mean, you said like few of our answers was right, but all of us had different mass, right?
But he's still determined by your work.
Yeah, that's, oh, okay.
A lot of people didn't even start the work, much less finish it.
Oh, okay. I'm good, man.
Okay? Copy this down. Okay? Repetition is a good way to learn something, and maybe that's what you need is to do it over and over again until you get it. All right? So far, I'm looking at what's done over here, and you're not even doing the steps much. I mean, I can understand if you plug something in wrong or kind of misunderstand what to put in there, but I've written this thing down about 4 times now. All right. What's so funny, Todd? That wasn't Todd?
She said life.
Life? Life's funny? Life is funny. And sad? Okay. So if I got to go from moles of the ending reactant to mass of the ending reactant, what do I have to get from here? Molar mass again. Okay, got to have those things. What now? Well, good. Listen, I'd stand on my head if I thought it'd help you.
Can you stand on your head?
I've done it and didn't help anybody, so I'm not doing it again.
No, it might help me.
You can stay on your
It'll
Hey,
help
you
you.
might fall down, you might break
It would like get us get our attention.
Yeah, but it's not getting you to learn this stuff any better.
Well, I mean, you know.
Just do the work, please. Just do the work, okay? I like to have fun like everybody else. I enjoy joking around, having fun, but if you're not getting this, and what it takes to get you to get it is to yell at you, I'll do that too.
Anyway.
If standing on my head, if I thought that would help, I'd do it. Okay, if doing jumping jacks would help, if my hanging from the ceiling would help you, I'd do it, but I don't think it's going to help you.
You ain't talking about me.
I know, I'm saying. That's what I'm saying, like I'm slowly about to stop.
Okay, just do this right now. Okay? You need to keep this solution map with you. You need to have it with you all the time. Okay? If you're solving one of these problems and you don't get the right answer and you don't have the solution map written down as part of your answer, you're choosing to fail. Now, if you can do it without the solution map, great. But if you're not getting the right answers, write down the solution map every time. Got that? Choosing not to do this and then getting the wrong answer is just choosing to fail. All right. So we're going to start with the mass of one of the reactants. It doesn't matter which one. Did anybody start with, if you started with calcium chloride, raise your hand. Just about everybody did, so I'm going to start with calcium chloride. If you started with the other one, you're going to get the same answer. It doesn't matter. Okay? If you did it right, 2 grams of calcium chloride. Did everybody get the formula for calcium chloride right? Okay? We need to have a molar mass. That's our next step. Right here, we've got to have molar mass to get to moles of that starting reactant. So I need to add up 1 calcium and 2 chlorines. Did everybody add up 1 calcium and 2 chlorines?
Yes, sir.
So we are getting somewhere. That's good.
I got 110.
Hold on a minute. I've got a number wrong in here, so just be patient with me here. I am not feeling well today. I was up a good part of the night. I've got a cold. I'm kind of doped up on cold medicine. So whoever it is that's been coughing in here is your fault.
It's not my fault. I'm taking
All right, is that what you got? Quiet, please. Quiet, please. Don't make me raise my voice to a higher level. Well, we don't need to because there's no empty slots over here to the right. Rounding off in addition and subtraction is all about empty slots to the right. Since there are no empty slots to the right, we don't have to round this one off. Yes, Amber.
That's your equality statement, right?
That is the equality statement right there. Very good. I know it. She must be taking some kind of mental Wheaties here.
Wait.
Wheaties.
Oh.
Wheaties.
Yeah, that's a nasty. That's good.
All right. Okay. So now we can cancel the units and species. And we can do this math. So then 2 divided by that number. And I got 0.180206.156 moles of calcium chloride. And I need to round that off to, this number has 3 digits, this one has 6. There's our measured number, our calculated number. Those are the ones we use to figure out significant digits. We ignore the counting numbers here, the 2 ones. Yes, Jessica?
I think there's a zero in front of the word.
Yeah, that's why I heard.
Oh, you know what? You're right. I apologize, guys.
Jessica.
Good deal. Okay? So, the leading zeros are not significant. Now we're going to round off.
So you did 6 because the calculated
What do you mean?
to determine the significant.
I look at the measured and calculated number here. And the one with the least digits is the one I choose. I choose that same number of digits as my final answer. Does that make sense? Did I hear somebody say no?
Not, I understand it, but I just don't understand how you did that one.
Okay, well this number has 3 significant digits. Do you see that? And this one has 6. Do you understand that? Okay. Those are the only 2 numbers we're going to worry about, or we're going to use when we're trying to figure out significant digits. So when we get over here, we're going to choose to have 3 significant digits, because this number has 3 significant digits. But these leading zeros are not significant. So
Oh, that's why I forgot.
the first significant digit is this 1. Okay.
I forgot.
Well, that's a very good question. I'm glad you asked it. That's taking charge of your own understanding. That's a good thing to do. Okay? All right, so we got 0.180 moles of calcium chloride. Now I need to find from the moles of that starting reactant. That's what I have right now. James, don't you think it'd be a good idea to pay attention? Moles of the starting amount up here. That's what we have right here in our solution map. We're going to go to the moles of the ending reactant through this molar ratio. And what do we have to have for to get a molar ratio? A balanced equation. You have to have an equation, a balanced equation to get that. Okay, so let's balance this equation based on what the problem tells us. So the problem tells us that we're going to start with, we're going to have 2 reactants. We're going to have calcium chloride, and we're going to have potassium sulfate. Potassium is K, sulfate is SO4. Get my test references over here. We need to figure out how to balance that formula. So I'm going to go to my periodic table that has the oxidation numbers to find potassium. Okay, and it has a 1+ charge. So if we need to balance it separately, we're going to put potassium with a 1+ charge down here. Sulfate's not on the periodic table itself, it's in the common ions list. So you go to your common ions list and you find sulfate. And if you search around long enough and carefully enough, you'll find sulfate on here. Has a -2 charge, yes. Okay. So SO4 with a 2 negative charge. And so the way I've shown you to do this math, and I would suggest, Dick, that you do this math every time if you're not good at that,